Hey folks, so I have a big update today. As you know, in my last video, we had completed the systems design and we had also wrapped up the organization of actions and action cards. So now we're moving into the phase of the production where I start doing all of the coding. I have since been able to complete about 2,500 lines of code. And a series of classes that cover the area of the stat development as well as the operations that are used inside of actions. And I'm going to break that down for you today. So, what I've been able to do is covered in the areas that are in green here in my layout. So, I began with the stat classes. Specifically, I started at the highest portion of the hierarchy, which is the dice class. The dice class breaks down exactly what dice are, and they feed into the stat definition class, which defines what a stat is, which may include an element of dice. Specifically, I have in my system a duality with intensity versus the core value of a stat. So the core value of a stat would be the way that a stat is represented as a whole number, whereas the intensity or its equivalent is represented as a dice number. So if you got like 4d12, for instance, 4d12 are 4d12s. It is also 48. Which is the maximum possible value. So what I needed to do was I needed to create a dice class, which represented the way that dice operate. Then I needed a way to interpret that, which is built into the dice class. Then I needed a stat definition, which gave a specific expression of that to say this is what a stat is, and it contains dice in this way. And then I have a stat class, which has all of the methods and operations that are needed for translating dice into whole numbers to be used in a variety of different ways. Then further, I extend that class in one of two ways. In one way, I extend it into what's called base stat. Base stat is basically a stat that has a floor of 0 and a cap that's equal to its intensity value. But it also has a proficiency. Not all stats necessarily are going to have a proficiency attached to them, but most base stats do. So an example of a base stat would be the core values of your character: vitality, physique, fortitude, that kind of thing. Whereas the stat class may be things like some simple derived values that don't necessarily need intensity. And can have variable states where there's a floor that may not necessarily be 0, might be higher, or a cap that may not necessarily be intensity, in which case you'd be looking at things like action pools or move or things like that. There is also the attribute, which extends from stat. So attribute doesn't have a proficiency value, but it does have a sliding value. Now, this is something like health or energy. And in my system, a character is KO'd when they reach 0, but they die when they reach a negative value, which matches their intensity value. So in this case, reaching into negative numbers is something that is enabled by the attribute class. So that also means that there has to be invocations at different points in time to assign the condition of KO and death. So a regular stat, for instance, is going to have an invocation for when you reach the floor, which is 0. I need to create a new thing called a median so that when it reaches the median, that creates an invocation that assigns a different stat. So in the case of like reaching base stat, when you reach the floor, the invocation in a base stat might be KO, whereas with an attribute, reaching the floor, which would be a negative number, would result in death, whereas reaching the median, which would be 0, that would assign KO. So this enables me to create 3 different kinds of stats within the game system. Which of course need to be stored in one of many different kinds of databases. So I have a unit stat database, weapon stat database, and an armor stat database. These are different stat arrangements that are assigned to different kinds of things within the game. Units, weapons, armor. And then, of course, I have controller classes, which enable me to manipulate what's inside the database, to assign and remove things from the database as needed. The total expression of these can be seen here. The dice class, which is roughly 82 lines long. And then I have a very simple stat definition class as a scriptable object. Then I have the stat class, which is built upon that. It's considerably longer, around 210 lines long. And it, of course, involves a lot of calculation elements and whatnot, so that if they're manipulated in the right way externally, all the ways that they can be manipulated will update things appropriately. And so that's exactly what this is doing. Then we have the extension, the base stat extension. We have the attribute class, which is the extension of stat. You'll notice that I have left median and median reached in both the case of this, the base stat, the stat, and the attribute. Those haven't been filled. That's because conditions have not been written yet. So I can't assign a condition or create a method for assigning a condition to this stat or to the character who owns the stat until the conditions classes have been written, because those things will just basically draw a whole bunch of errors until they're actually something that I can call upon. Then we have, of course, the unit stat controller, which is basically going to be a way to initialize and manage all of the stats within the unit stat database, which is fairly small and includes stats, attributes, and base stats. So this is like the most simplest form. And what I would do from this is then take that, go inside of the Unity editor, and build up the UI toolkit to be able to instance these things, to be able to create things like fortitude, physique, those being base stats, health and energy, those being attributes, or move and action pools, those being stats. Likewise, if you've got weapon stats, you're going to have things like reach, you're going to have things like material values and stuff like that that might be shared between that and armor stats. So that was the assembly for the stat portion. And then I moved into operations. And operations turned out to be much more complicated than what I was expecting. So operations had to go through a pretty large reconfiguration. The starting point for me was the operation handler and its behaviors, but it meant that I was going a lot, basically in circles. So what we have is an operation definition. This defines what an operation is, what it contains. This, of course, is then instanced as an operation. The operation definition being a scriptable object, so it is protected. An operation being the place where the operation's main functions are managed. It became clear to me that I didn't want to load all the methods for manipulating an operation inside of the operation itself, because the operations get moved around from action to action. They get inherited by cards, by actions, and all sorts of other things. So that turned into the operation handler. And the operation handler became a bit of a nightmare, because defining how the operation handler worked was not so much about developing operations as it was about developing the operation groups, the way that they're organized inside of cards. So I ended up basically going around in circles, where I ended up having to touch on the card definition, the card, and the training model in order to be able to define what an operation group was, to be able to give the correct behaviors to an operation handler, which in turn defined what was going to exist inside of the operation, by extension, the operation definition. Finally, when these things wrapped up, I was able to build an operations database. But this, of course, created other issues where it became clear to me that if I was to do something like merging operations, which is there's this, I created a real nightmare for myself. Is basically what I did. I said, okay, well, we're going to do training. And that means that we're going to take something like an action, and then we're going to have a power, and then we're going to combine those operation groups. The problem is it's not truly modular. In some cases, things are being merged. Some cases, things are being overridden. And so new operations are kind of being created. And this was an opening for all sorts of bad coding problems. So basically, imagine this. You have an operation, and then this operation is managing, for instance, targeting of a specific in a ranged attack. So the targeting operation exists within the operation group for a ranged attack. Basic, simple, I'm shooting a gun at a person. The shooting a gun at a person requires multiple operations. It requires the action declaration. It requires targeting. It requires success criteria. Then it requires a damage roll. Targeting is one of those operations. So you have an operation called targeting. Then you have a technique card, and you want to attach the technique to this particular action. So one way to do that would be to swap the targeting operation for another targeting operation. The problem is the technique card is not going to care if the action has one or multiple targets. It's supposed to do the same thing to all actions of a certain type. So it doesn't matter if it's a barrage attack or if it's, a semi-automatic attack, which is just a single shot. So if you have the single shot attack versus the barrage attack, that technique is going to have to replace the targeting parameter regardless, so it became easier to modify it. The technique, let's say arcing shot, would extend its range. So I needed it to be able to extend its range, which meant that it needed to be able to merge a portion of that operation with the other operation, which ultimately would change that operation for all players at all times, which is not what you want, because the system isn't going to know that you just modified this operation in this one instance at this one point in time. It's going to modify that operation for all instances of that operation. So suddenly, every barrage for every character in every instance of that database is suddenly going to be altered because you trained. That's not what you want to have happen. What you want to have happen is you want to have this new action created that's a customized version of that, which means a new operation needs to be created when you merge these things, at least a new instance within the system. And to do that, I needed to create, I basically created a totally different problem within the architecture of the game, because I'm able to kit bash and build this thing as I go. I can basically say, all right, well, take this card, put this card down, take this card, put it over here. No, I don't like that. I'm going to swap with this other card. Well, every time I do that and switch back and switch forward, I'm creating a new instance. And this means that I am creating instances upon instances upon instances upon instances just by playing around inside of the training, inside of the training model for the game. So the crafting mechanism becomes a leaky code production house for creating operations that just sit dead inside of the system and weigh it all down. So I needed to either approach this as a caching problem, where I've got a temporary set of attributes. That wasn't going to work in all cases. Or the other option was to create a dummy list or dummy database of temporary actions that are not necessarily committed, and then dump those into make a way to make them permanent. And so what I decided to do was in the operations database, I created two classes of groups. Um, and I'll pull this up here. So we have standard operations and dynamic operations. So standard operations would be designed exclusively and committed exclusively by the game developers, myself. We create them to be able to put them onto cards so players can use them. The dynamic operations group is there for when the operations get created inside of the trainer. The dynamic operations group will clean itself, basically. There are moments when I have the opportunity to create a cleaner operation or a method, or it's called, which checks for instances. And this meant that I needed to create a system for reference counts so that it was clear every time an operation was committed or added to something, then a new reference for that operation was created. And whenever we decremate, basically remove an operation from an action or an operation group, that its reference is removed. This created a whole nightmare that I had to deal with in the operations handler. So the operations handler turned out to be one of the most complicated things I ended up writing. It ended up being 360 lines of code. The operation definition was 67. The operation itself was 197. And then we had the operation group, which is the place that houses all of the operations. The database, which is two forms of list. And then we have the beginnings of the training group, the training model, which I needed to touch on in order to be able to make it all work. But the operation handler specifically was an absolute nightmare, and it took me a week and a half, and I didn't make videos because during that space of time, 100% of my brain power was committed to trying to make sure I didn't forget how this thing was working and what was missing from it. So once I got the operation handler working and the unit tests were working, I can officially say that I am ready to move into cards and into the card controller, the operations controller. Again, UI toolkit will be built on top of this so I can instance out more of these elements. And then I'd be leaning towards creating the training model or a dummy version of the training model that demonstrates how to build an action using these components. As it stands right now, I'm actually, I ended up building some part of the underlying operation system. So whether I meant to or not, operations group and the operation handler has effectively created the method queue and the cleared method system, as well as portions of the turn manager. So whether I intended to build it this way or not, I created a de facto tool for generating all of the components I needed in the session handler, which is going to make that job a lot easier in the future. That said, I am changing tack a little bit. I will continue to work on this. I'm slowly working my way towards substantial completion of the training model. To me, the training model is going to be the trickiest part of this to build. And so I want to go as far as I can and build the UI toolkit on top of that to be able to generate all of the instances of the existing cards and then demonstrate that it is functioning before I move into creating full unit lists and all that other kind of thing. But we live in tough times, and there are a lot of inflationary pressures right now that are making things tough on my family. So I've made the decision that because I have to do it anyway, I am going to shift my focus a little bit towards producing the 3D models. And that means that I will have something that I can retail by doing my best to produce as many models as I possibly can, and as in the space of time that I have, which is a change in my original schedule. It means that I'm going to be doing more art up front, and that this portion of the process will slow down. But that means, of course, that you're going to see more art drops for me in the coming months. And I'll be making, hopefully, an announcement sometime in the near future about retail sale, probably through my mini factory, of some of the 3D models. I'm going to be focusing on like kind of legendary characters and stuff within this, and not necessarily playable characters, I think. Which of course, building the legends creates the base meshes that enables me to create the simple models that will ultimately be the ones that you can print and use to play. Right now, I'm focusing on statuesque, high quality models that build things out, and hopefully, get things rolling and give you a way to support this effort and this channel. So that's my update today, and next week, modeling.